Hello folks, this is Mr. McAllen, and today we're going to talk about solving exponential and logarithmic equations. Remember that when you are solving an exponential equation, you're going to try to isolate the exponential part, just like you would normally isolate the x or the y that you're solving for, and then you're going to use a logarithm to reverse the effect of the exponential part. Likewise, if you're solving a logarithmic equation, you're going to isolate the logarithm and then use exponential functions of the same base to undo those logarithms. So that being said, let's take a look at the first question. The first question is solving an exponential equation. So when we look at it, you want to isolate the exponential part with the base and the exponent. So I'm going to solve for 1/8 to the x, and that's going to equal 5 over 25. Now 5 over 25 is going to equal 1/5. So I have 1/8 to the x is equal to 1/5. So now I have a function that I don't know what I raised 1/8 to get me to 1/5. So what I'm going to do is I'm going to use I'm going to rewrite this in terms of a base 8 exponential. So this will become 8 to the negative first to the x power equals 1/5. I'm going to then rewrite this as 8 to the negative x using properties of exponents. And now to undo the base 8 exponential, I'm going to use, in this case, I'm going to use a base 8 logarithm. So I'm going to do log base 8 of 8 to the negative x equals log base 8 of 1/5. I'm going to use my calculator to find out what that value is. On this side, since log base 8 and 8 to the x are inverses, they just wipe each other out, and I'm left with negative x is equal to whatever log base 8 of 1/5 is. Now today in class, we learned about change of base formula. We also learned about using the special button on the calculator that is a generic logarithm button. So I'm going to pause the video and use a calculator, I'm going to pause the video and use a calculator, and then I'm going to have the value for what log base 8 of 1/5 is. I'm back, and I used my calculator. Actually, I used on my phone the Wabbit MU, which is an emulator for Texas Instruments. So I got, in using the change of base, I did common log of 0.2 over the common log of 8, and that gave me negative 0.7739, and now I know my x value is 0.7739. So I should check that in the original equation, but being for this video I don't want to take up too much time, but you should always take your answer and plug it back into the original and see if it actually works. So that would be good practice, but for this video I don't want to waste too much time. I want to do some more equation solving. So now on the next problem, I have another exponential that will work in a similar way. So I have 5 to the x over 2 power times 3 equals 125. So again, it's an exponential equation I'm solving, so I want to isolate the exponent part and solve using logarithms eventually. So what I'm going to do first is I'm going to rewrite this as 5 to the x over 2. I'm going to divide by 3, and that's going to give me, you know what, I'm going to just, sorry guys, I'm going to cheat a little bit. I'm going to change this to 75 because I want this problem to work out a certain way. So when I divide by 3, I'm going to get 25 on this side. Now in this case, this is a special situation where I can rewrite both sides in terms of base 5 exponents. So what I'm going to do is I'm going to leave this left side as x over 2, but the right side will become 5 squared. Now because the left side and the right side are both base 5 exponents, I can just focus on solving for the exponent part. So this is an example of a textbook math problem where the answers work out real nice and neat for you, and you don't need to use logarithms. So I can just set x over 2 is equal to 2, and as a result, when I cross multiply, I'm going to get my value to be x is equal to 4. That satisfies this equation. Looking at the equation up here, if I plug a 4 in, I'm going to get 5 to the 4th power over 2, which will be 5 squared. 5 squared is 25 times 3. The answer checks out as 75. Now we're going to switch our attention to solving a logarithmic equation. Remember, a logarithm is just the inverse of an exponential. So in this case, my logarithm is already written as just a logarithm is equal to a number. So all I have to do is change this form to exponential form, and if I raise both sides to the base 5, so I'll put a big base 5 there and a big base 5 there, the base 5 undoes the logarithm. I just have x minus 1 is equal to 5 to the negative 2nd power. Now 5 to the negative 2nd power is, you got to be careful with this, it's not 25, it's 1 over 25. And then my x value is going to equal 1 and 1/25, because I'm going to add 1 to both sides, or some people would call this 26 over 25. You should always take your value that you find and make sure that you don't have an extraneous solution, and that is actually going to work for you. So in this case, if I plug in 25 over 26, I'm going to get the log of base 5 of 25 over 26 minus 1, and that will work out to give me negative 2 for sure. So on the next problem, we have a natural log plus another natural log equals another natural log. So in this case, we're going to use some properties that we studied yesterday in studying logarithms, as far as to compress the logarithm. So we learned that when you add logarithms, you can rewrite it as one logarithm being multiplied. So in this case, I'm going to compress the left side. And that's going to equal the right side. I also want to take care of this coefficient, because if I have a logarithm is equal to a logarithm on the other side, I can just drop the logarithms, or, well, I'll show you what I mean by that. So I got natural log of 3x plus 2 times x minus 1, and then that's going to equal the natural log of x squared. Okay, that's great. So now I can either forget about the natural logarithms, or I can use its inverse function for both sides, and that would be the exponential. That essentially wipes out the natural logarithm, and now I'm just solving 3x plus 2 times x minus 1 equals x squared. I'm going to FOIL, or multiply polynomials. So I've got 3x squared plus 2x minus 3x minus 2 equals x squared. I'm going to bring everything over to one side because it's quadratic. I have 2x squared minus x minus 2 equals 0. And I'm going to factor this problem. So now I'm going to just pause the video while I factor it. I don't want to waste your time with factoring. And then when I come back, I'll have the solution. And if I don't have if this isn't factorable by using integers, I'm going to use a quadratic formula. So at this point, it's really just equation solving on a quadratic equation. Okay, so I'm back, and this is the trouble with making up a problem. I just kind of made up a problem to see how this would work out. But what ends up happening with this quadratic is it's not factorable using integers. Most of the problems that we're going to do from the textbook should work out. But in this case, the solution to this quadratic, we're going to have 1 plus root 17 over 4, and the other root will be 1 minus root 17 over 4. Now here's the thing, you can never have a negative number inside of a logarithm, otherwise the solution won't work. So even though these answers may be decimal in form, you know, you're going to get a number that you're going to plug into your original logarithm. Hopefully it will work, but if it makes your logarithm negative, you have to throw out the solution as extraneous. So you know, that's just one of the pitfalls of, you know, I just try to make up a couple example problems to show you guys. And you know, in this case, I kind of lost as far as making a problem that factors nicely. Anyway, the general idea of how you solve this equation is still true, though. You compress the logarithms in the first step. In the second step, you get rid of the you get rid of the natural logs by using the exponential inverse, and then in this case, I had to factor, which wasn't easy to do, so I used the quadratic formula. In the next problem, it's a little bit of a reprieve from the difficult math problem that I had before. So here I have a common log of x squared equals 2. Now in this case, I don't really have too much work to do. I just have to change this to use the inverse of common log, which is base 10. So I'll use base 10 on both sides. And that will remove the logarithm, common logarithm. So I have x squared is equal to 10 squared. And as a result, you have x squared is equal to 100. And x will equal plus or minus 10. Now here you have to check your answer. I have log of x squared equals 2. But in this case, no matter if I put 10 or negative 10 into the logarithm, it's going to be squared. So it will make the value going into the logarithm positive, and both solutions would be sufficient. Last problem is solving a nasty looking logistic problem. Notice the carrying capacity is 500. We want to find out at what x value do we get to a population of 200. So what we're going to do is, remember, we want to isolate the exponential, and then we want to use the logarithm, the correct logarithm, which in this case would be natural logarithm, to undo that exponential. So here we go. We're going to cross multiply. So I have 500 over 200 equals 1 plus 2e to the 0.3x. This is going to be 2.5 is equal to 1 plus 2e to the 3x. I'm going to subtract the 1, so I have 1.5 equals 2e to the 3x, 0.3x, my bad. So remember, we're trying to isolate e, and we want to get rid of that coefficient, so I'm going to divide both sides by 2. So 1.5 divided by 2 is going to be equal e to the 0.3x. And now here's a point where I'm going to use a natural logarithm to get rid of e, but I've got to do it to both sides. So natural log of 1.5 over 2 equals 0.3x. So I'm going to use my calculator, and that's going to say a natural log of 1.5 divided by 2, and that's equal to negative 0.28768, enough decimal places, 0.3x, and I just divide by 0.3, and the x value is going to be divided by 0.3. Nope. Always double check what you put in the calculator, and that is x will equal negative 0.9589. Let me just double check my work. Okay, and we're looking for when this is going to be 200, and it's suggesting from the equation that that we would have a negative time, which means that this value must have happened before we said time initially starts. Let me just make sure. I may have copied the problem wrong, and that may result in why we have the negative answer for x. But all the same, we can just plug that x value back into the original equation and see if the equation works out, just to make sure that we're solving the equation properly. I hope this video has helped you understand some basic ideas on how to solve exponential and logarithmic equations, and I look forward to hearing your comments either in class or if you just watch the video and want to comment.